So 274, isn't that what it is? 74, 75? Yeah. And today is the 13th. And I told y'all, when I mess up the year, I mess it up really bad. Yesterday I put 11. I put like 1, 12, 11. I told you, I don't mess it up just by putting a 20. I go really crazy. Make sure you spell it right. And they kind of tell you what they are, because parallel, it's got something to do with parallel lines. Now, first we want to today we're mostly just telling all the things about parallelograms. And as bad as it looks, within the family of parallelograms, you have squares and rectangles and rhombuses, and all of those have these same characteristics. So don't get, we had a lot of formulas over here. I know I pushed you a lot through 33. This one, we want to kind of look just at the quadrilateral here, just a refresher, what I said a while ago, has 4 sides, 4 angles, 360 degrees. And that's one, I think it was Taylor a while ago, I just said, that's one you want to know. I mean, you're not going to always remember how many degrees are in a pentagon or hexagon. I don't either. I have to do that, subtract and, multiply by 180, but that's one you want to know, like a triangle. Triangle's got 180, quadrilateral's got 360. Now we want to look at a parallelogram, and there was not just a parallelogram on this one. The newest geometer has, and I think I was right, actually it does have a little bitty one down here, and this one is a parallelogram, but it's also a rhombus, so I don't want you to be deceived by what it looks like. So I pulled the old one, and I tried to give you a decent one. Now, most everybody's, let me show you first. I think one person has the geometer that the parallelogram is up here, and it's number 10. But I think everybody else, it's down here, isn't it? Is it down in the corner? And what's the number? Does it have a number on it? It's 30 on, but I think one person, I didn't have 12. Well, y'all may have all gotten them. It may be the one up there. So is everybody's number 10? On your geometer is number 10 this, the parallelogram. It's down here. Oh, that's right. I've got the one that's not. So is everybody's number 30? Is it 30? 33. Okay. Is everybody's number 33? Okay. That's the one we want. Mine's number 10, but that's okay. I'm telling you, I've got probably 5 or 6 different geometers, different companies, and they copyright them, so they'll just take it and change the stuff around and then copyright it from their company. It doesn't seem fair, but that's the way they do it. So they all kind of use the same format. So some of them I like. This is the old one, I think, and it was always my favorite because it tended to have better stuff on it. But that's okay. This is a parallelogram. Now, we need to go ahead and give it some vertices. So we're going to call it ABCD. So how do we write that? We really just do a baby parallelogram and call it parallelogram ABCD. Now, there's a lot of names because you can go all the way around it. ABCD, BCD, you just got to go consecutive. You got to go continuous that way or that way. I'm not going to name them all. We usually just do it alphabetically. Okay, lots of things that are true about them. Number 1, this is why it's called a parallelogram. Opposite sides are, and I'm going to write the word parallel. Now let's use the symbol. Opposite sides, what does that mean? They are across from each other. So AB, segment AB, sides or segments, is parallel to DC or CD, whichever way you want to say it. Do they look parallel? Yes, that's why we like to use the geometer, because when I freehand them, they don't always look that way. There's another set. AD, I'll put a comma, segment AD is going to be parallel to segment BC. Now, a lot of what we're fixing to say now comes from parallel lines And, oh, there's that stuff we did a long time ago. Alternate interior angles congruent, consecutive interiors, especially that one. Consecutive interiors supplementary, some of that stuff. So a lot of this goes back to old stuff that we've said. Number 2. We love this one, and I will start abbreviating here. Opposite sides are congruent. Now, we like that one. Now, the difference in that rhombus on the other one, and a rhombus is like a pushed over square. It's all the sides are the same, but you push it over. So that's why I didn't want to use that rhombus on the other one, because it's obvious AD and AB are not the same. But in this, opposite sides are congruent. So segment AB is congruent to segment DC. Let's mark it. AB, DC. I'm going to put a lot of markings on these. Oh, by the way, how do we show parallel? Remember the little arrows? We probably won't use this picture because it's going to have a lot of stuff on it. I'm actually going to fill mine in like that. I'm going to do that. Actually, I'm going to even do this. It'll show up better. And then this one is parallel to this one. I forgot about that. So we're marking what we know. And then the other side, so AD is congruent to BC. So don't get freaked out by all the information, because what happens under the family of quadrilaterals, over here on the side, now you've got trapezoids, we'll do those later, but then you've got parallelograms. And then under parallelograms, like I said, is square, rhombus, and rectangle, and all of those are parallelograms. So they have all of these characteristics, and we just add some more. Number 3, opposite angles are congruent. Hey, that's a big one right there. Now, what do we mean by opposite angles? Opposite, across from each other. Name me the ones that are across from each other. Angle A would be congruent to angle C. So if this is 80 degrees, this is 80 degrees. Well, those are actually obtuse, aren't they? So if it's 160 degrees, that's 160. What's the other pair? Angle B is congruent to angle D. Number 4. This is the last one. And this actually comes from, oh, I didn't circle those. I'll go back and do what I was doing to the other. This one actually comes from the idea of these being parallel lines. Do we need to mark anything? Yeah. Angle A is congruent to angle C. Angle D is congruent to angle B. Number 4, consecutive. Now, we don't have to say interior because you only have interior here. So consecutive angles are supplementary. They're not linear pair because they're not next to each other. But supplementary means they do what? What supplementary angles? That's an oldie one. That's like early angle pairs, wasn't it? There it is, lesson 6. Oh, there it is. Supplementary angles are two angles whose what? Sum is 180. Now, look what it says. Consecutive angles, that's one right after the other. So there's a bunch of them. The measure of angle A plus the measure of angle D equals 180 degrees. These two. Let's just go around it. Measure of angle D plus measure of angle C equals 180. Measure of angle C plus the measure of angle B equals 180. Is there one more? Measure of angle B plus measure of angle A equals 180. So when it looks like a lot of stuff, here's your biggie right here. These two are the same. These two are the same. These add to 180. These add to 180. These add to 180. These add to 180. Surprise, surprise. 180 plus 180. The whole thing adds to 360. So don't forget that up there. We're going to do more on Friday. It gets a little bit crazier. We do some things with diagonals and stuff. But let's do a problem like you have in classwork today. So redraw that number whatever it is on yours, 33 I think y'all said. Yeah, it looks like the picture in mine from last year, I used the old geometry and do that little bitty one on here on the one from last year. But because I had 24 people in class, I didn't have enough of these. So this way. So if we say it's a parallelogram, L, M, N, K, so we've got parallelogram, L, M, N, ooh, I guess I didn't, K, there we go. If we do it alphabetically, we'll say K, L, M, N. You can list it anywhere you want to. Okay, what are we going to put on this? I'm going to put that LK is 31, and I don't know if they've gone back. Sorry, Daniel, and everybody. If they've started putting units on those, but that's units, like 31 inches or whatever. And I think they did upgrade the generator that I used to maybe put units on them. And then we're going to let this one be 45 units. And we're going to let angle L be 100 and, if I can read my writing, 119 degrees. So, over to the side. M, N equals. Now remember, without a bar, that means the measures. Put your blank. KN equals blank. Measure of angle K equals blank. Measure of angle N equals blank. Measure of angle M equals blank. We've done problems like this with triangles. Now we're doing it with parallelograms. Now this is me. The first thing I'm going to do is knock those sides out because sides are easy. If LM is 45, which other one do I know is 45? KN. I'm going to write it on my picture. KN is 45 units, whatever that is. If your classwork has units on it, put the units on it. You know, 45 inches, centimeters, whatever it says. So if KL is 31, what's MN? 31. Okay, now let's do angles. Let's do the easiest one. Which one is exactly the same as L? I'll give you an easy point. You're going to have, unless it's a rectangle, you're going to have in a rectangle and square all 90. But here, you'll always have two obtuse and two acute, and the obtuse will be the same and the acute will be the same. So I know N is 119. Be sure and put degrees on it. Now, how would I get K and M? Yeah, just do 180, because I know these two add up to 180, these two add up to 180. They have to be 180, because that's the only way you're going to get 360 out of this thing. So 180 minus 119 leaves you 61. And if you put 61 here, 61 plus 119 plus 61 plus 119, surprise, surprise, is 360. Number 2, page 75. Everybody good? Okay, pretty straightforward.